Hello everyone and welcome to today's webinar. I'm joined today by Richard Root and Bassam Salam from MTC, who will be speaking to us today about their Smart Manufacturing Accelerator solution. Today's agenda will include an introduction to the factory in a box. Then we'll be finding out what is a Smart Manufacturing Accelerator. Then why Wonderware was selected as the software solution. After that, we'll take a look at the control center demonstration of operating a factory in a box. And then we'll wrap up with a summary and conclusion. So on that note, I'll be handing over to Richard.
Thank you very much, Tim. My name is Richard, and I start off with giving a little bit of background about how this project started. The Smart Manufacturing came out of the TIERA project, and TIERA stands for Thermal Energy Research Accelerator, which is an initiative here in the UK funded by Innovate UK. It is based in the Midlands with a number of universities. So here at the MTC, we work together with the universities of Birmingham and Loughborough to build a factory in the box. And that factory in the box was for a specific purpose for thermal energy. There's a company called Dearman who invented a zero emissions engine. That's a refrigeration engine that runs off liquid nitrogen. It uses the expansion of liquid nitrogen for the cooling process. So for that, the company needs pipe assemblies, and our factory in the box is able to make those pipe assemblies. And there's a shortage here of cryogenic welding skills, hence the use case to build the factory in the box as a demonstrator. So on the next page, here is a CAD drawing of our factory in the box. So it starts, we've got a pipe storage, then the cutting machine. Here at the heart is the brazing station, which use induction brazing for the T-pieces and end pieces. Then we have a bending post, we have a leak test station, and there's also a vision system installed. And throughout the box there's a gantry for the robot arm to move all across. We will now show you a short video with some more information about the Smart Manufacturing Accelerator. The video takes about 2 minutes and shows our recent launch event. It also contains some live footage of our factory in the box that was taken during the event.
Today is really, really exciting. It is a chance to bring together a community of business to play before them a great opportunity, which is transformation of how one can do manufacturing for the UK business sector. The Energy Research Accelerator has been working to develop the factory in a box for the last 5 years. And this today culminates that journey, the production of the factory in a box, the first factory in a box.
The factory in a box concept is really exciting. I think it shows why the UK is seen as a world leader in high value manufacturing, and the fact that you can do a lot of this really clever innovation literally in what is a shipping container. You can take the raw materials from one end all the way to an end product at the other with minimal human intervention is absolutely incredible. And the fact you can actually control from the other side of the world a manufacturing process from the UK, it really is exciting, world leading, and I think this does give the UK a massive opportunity.
The way those guys have presented the concepts is really clear for me as a mechanical engineer, They've walked through a process that's relatively simple so that I can understand it, and then begin to fill in the detailed technical tools over the top so that we can then discuss that with large companies and startups. A startup can see how they can use this tool to then get to market faster. An investor can see how they can use this tool to get their startup to market faster. And the big corporates can see how they can apply it into a traditional large-scale manufacturing environment and a large-scale factory. So I've been thoroughly impressed by the whole day.
So the Smart Manufacturing Accelerator is to reuse the knowledge and templates that we produced during this project and help companies building smart manufacturing solutions or similar to our factory in the box to create a portable manufacturing solution so that it's rapidly deployable, remotely managed. So that was one of our key aspirations. Hence, we needed digital technologies to enable that. And a couple of other aspirations we had in the project were the production optimization, quality and traceability, predictive maintenance, and also we wanted to make sure, because of the remote connectivity between the control center and the factory in the box, that it's digitally secure. So we have a website where we have a video that you can have a look at. The website also shows this diagram, which is our methodology, and that's the services we are delivering as MTC to help plan, design and build, and also explain how to operate a factory in the box. So today we will showing you our remote control center that we built with the InTouch OMI solution of Bondo Air. Before we do that, we show you why we selected Bondo Air. So first of all, it met our functional requirements. So we looked at quite a number of different softwares to use for our solution. And what we did, we started off with our aspirations, then our requirements. And based on the requirements, we created selection criteria, which we put in a few matrix, which is a methodology that gives weighing factors to your selection criteria. And based on that, the Bondo Air solution scored very high. Another plus for us is that we also wanted to demonstrate new technologies, Industry 4.0, and we're keen to demonstrate how to use cloud solutions in a secure manner. So the Bondo Air solution is integrated with AVEVA Insight. So that made it for us relatively easy to develop our predictive maintenance scenarios. On the next slide, I'll show you a little bit more about that. Once we got the project on its way, we needed to build our remote control center. And our objective was to create one single user interface. And we looked at different products, and then we came across OMI, InTouch OMI, and that made it really easy for us to build the control center. So we were quite impressed that we were able, within about 2 weeks, to already have a working proof of concept, which was very promising. And we will show you later how it now evolved to a mature product. Then here at MTC, we work with a lot of different companies. So one of our aims is to be vendor agnostic. You will see at the next slide the number of partners that were involved in this project. So for us, it was very important to find a solution that is easy to integrate with other solutions, and that's exactly what Bondo Air offers. It has a lot of different integration options, both horizontal and vertical, which is a big plus for us. Then last but not least, we wanted our demonstrator to be industry relevant. So we want to have it on a relatively high manufacturing readiness level, or MRL or TRL level. And that's also achieved with Bondo Air. So it was relatively easy to build the solutions. And what really impressed me personally, after we did a lot of work developing the control systems, independent of that, another team developed the MES and the control center integration. And then we had to bring the two together. And it was really quite impressive how quickly, how less time we needed to bring that together. That was really good. Before I hand over to my colleague Basim for the control center demonstration, just give you a little bit of an overview of our systems platform, or our systems landscape. So here on this slide, you can see this big box which represents our factory in the box, with on the left the various types of equipment, a couple of examples. So in the box we have a backup server, which is also the control system. So the assets are connected to the control center, to the control system, and also for data acquisition. So the data acquisition is then stored locally in the Bondo Air Historian. We have an MES locally in the box. We also use other products, as you can see. So as mentioned earlier in the presentation, we also use cloud applications. So here we have the AVEVA Insight, which gets data from the online historian. So part of the data is replicated to AVEVA Insight. And then we have a predictive platform that does the predictive maintenance analytics, as well as a computer-based management system, or asset management system. We also use, in our example, a discrete event simulation. So that's what we all do in the cloud, and we can see the integration in a minute. And then also we have a few on-premise solutions. Some of them are desktop applications, some are in our data center. So we have a robot, so we need to do the robot path. So we work with a company in Scarborough for the pipe bending. And we have also virtual reality and augmented reality use cases. On the slide, you can also see the references to our cybersecurity. So we particularly looked at the NIST cybersecurity framework, but also worked with NCSC or used their documentation to come up with an overall secure solution. And then here at the top is our remote control center. So with that, I'll hand over to my colleague Basim. So for that, we log on to there we are, control center.
Thank you, Richard. So this is Basim, and I will go with you through the remote control center that we developed for Tierra. We're currently on the landing page, and at this page we can see the different factory boxes or FIABs that we're managing from this system. We can see the status of every factory box with the alarms active, the environment information inside and outside the factory box, and the KPIs of how these FIABs are performing. So for today's demonstration, we will use FIAB number 4, which is like a simulated model from the factory box we have. Clicking on any of the FIABs, it will take us to the machine monitoring page, and at this page we can see the different systems layout, a live feed from the sensors installed on the different machines, and a list of active alarms. So if I can simulate some alarms here, we can see the details list with the alarm severity. Clicking on one of the systems will give us like the same view for that particular asset. So here we can see a cutting machine simulating a cutting operation, As you can see, the cutting disc health is a bit low, so we're getting like an excessive vibration, so the operator is getting an alarm regarding that. And the way this is working, as Richard difference in the architecture, we're collecting all this data, historize it locally, and then send it through Wonderware online to Sensei, which provide these asset health estimates. And from this page here, the operator can click the maintenance button, which will connect to Ultimo on the cloud to get the scheduled maintenance work order for that particular asset. Here on the left-hand side, we can see the different capabilities of the Factory-in-a-Box. It starts from order management and optimization, where we have our assembly catalog. This is the type of assemblies that we produce inside the Factory-in-a-Box. Also, we have a sales order screen, which we use as a starting point for us to receive sales orders, creating production orders out of them. And then we have stock use optimization. So inside the FIAB, we're using an optimization tool called FICO to perform some stock use optimization. So we minimize the amount of off-cut or pipe waste generated from the cutting operation. So here we can see an unoptimized cutting sequence. We can see like summary of that run for a set of work orders and how pipes would be consumed. Clicking on the optimized stock use, what the portal will do, it will export the jobs from the Wonderware MES to FICO. FICO will run the optimization algorithm, and then after an optimization is performed, it will automatically import these jobs back to Wonderware MES, ready to be executed. So here we can see the optimized cutting sequence, and we already achieved around 33% of optimization with 0% off-cut generated, with 0 off-cut generated. Similarly, we can do a production planning application to do scheduling optimization and some what-if planning. Second category we have is for remote monitoring and control. This is to release production into the Factory-in-a-Box and to monitor the progress. If I click on the production execution dashboard, we can see that we have the scheduled jobs, the parameters that are sent to the control system and the status of that job, and the stock levels currently inside the Factory-in-a-Box. If I click on the complete button here to complete that operation or to simulate the completion of that operation, the MES will move to the next job. So it's worth mentioning that the FIAB itself is a highly automated cell. So once we release production, the Wonderware MES will progress automatically through production orders one after another. In case an assembly failed a quality test, it will automatically cancel related jobs and proceed to the next production order. In case like a machine fault detected, the MES will again acknowledge that and suspend production. So this is a leak test, one of the quality tests we perform, where we pressurize the assembly to a certain pressure limit, and then for a set period of time, we monitor pressure and temperature against the quality specifications that are defined into the manufacturing execution system. And based on that, the MES determined if the assembly passed or failed that certain quality test. On this dashboard, the operator also have access to a predictive discrete event simulation tool. This is powered by Witness and hosted on Predix. Once it's loaded, here the operator can see the initial completion estimate, current order progress, and an updated completion estimate. And the updated estimate takes into account the machine status. So if one of the machine will fail soon, it will accommodate for that. Here also we see the estimation variability. And on the asset utilization page, we can see how the different assets will be utilized during the current production cycle. Going back to our capabilities, we have a hardware-in-loop dashboard, which is a 3D pneumatic model of the Factory-in-a-Box in operation. We also have stock management. This is where the operator, this is the dashboard that the operator can use to replenish stock and issue assemblies from the Factory-in-a-Box. So the dashboard themselves can run like from a surface or a tablet, so the operator can use them while like replenishing the component. Third category is for quality management, and on the assembly quality dashboard, here we can see that everything we produce inside the Factory-in-a-Box is completely traceable, starting from the batch number of the different components used, size, lengths, results of the quality test, So these are pressure and temperature profiles during the leak test. These are the results of visual inspection. The operator even have access to the actual image taken for that asset. Even though we historize the status of the different machine when performing a job. So for example, when we did cut the first pipe, we can see the cutting disc vibration, and this tool the operator can use to identify any quality issues. Cutting motor current, so we will see the trends coming back. So probably that was connection glitch. So second quality dashboard we have is the FIAB overall quality, where the operator can see some statistics about the results of the FIAB production, amount of assembly passed, what type of quality tests are failed, and the work order related to these statistics. The last category we have is about maintenance management. So we have different maintenance capabilities inside the factory box, starting from condition monitoring performed at the edge to more like higher level predictive maintenance. So the first dashboard we have, the maintenance assessment. This is where for one of the test rig we have, so we can see the different condition monitoring aggregation. So the blue line represents when the test rig was performing in normal condition, and the red line is when we introduced a failure. And the failure we introduced in this particular instance is a shaft imbalance. So we can see at the SST the spikes when we introduced that failure. Second dashboard we have is predictive maintenance, which takes us to the Sensite dashboard. So the operator can go through the different insights and asset health on that platform. And the last dashboard is for automated maintenance order. So here we can see the gas supply for the brazing station inside the factory box. The supply itself is equipped with like flow sensors reading and regulators. And the goal of that is that when a leak is detected, the control system will detect a drop from the flow sensors, and it will trigger one of the regulators to kick in to compensate for that particular leak, so we don't ruin the quality of the current brazing active. However, at the same time, an alarm has been triggered, so an operator can check the issue. And if we go to Ultimo, the cloud maintenance management system we use, we will find out that a maintenance work order has been scheduled. So here we can see that maintenance order is scheduled, and an operator will get a notification to come and check the issue. So that's the end of our remote control center demonstration. I will hand over now to Tim to conclude this webinar.
Many thanks for that innovative demonstration. If we just go back to the PowerPoint. So to summarize from a Wonderware perspective, what it does, it showcases a discrete implementation of the Wonderware MES. It also enables the Aviva IoT platform to help with the predictive maintenance of this application. And finally, the InTouch OMI interface brings all these different systems into one place to enhance the operator experience. So again, a big thank you to Richard and Bassam from the MTC for presenting their Smart Manufacturing Accelerator solution to us today. And I think with that, we'll be unmuting the lines and take any questions that any of you may have. Okay, so with that, we'll wrap this webinar up. So again, thank you very much for your time today, and thank you both for your time from the MTC. Thank you.